Hello everyone, in this lesson we will continue to learn the time domain analysis module of continuous systems. This lecture we will discuss a solution of zero input and zero state response. The zero input response of the system is actually to find the homogeneous solution of the system equation. The undetermined coefficient in homogeneous solution is solved by the initial state value of non-zero system. Zero state response of the system due to the initial state of zero, and response is generated by motivation. If the excitation signal is not zero, the right end of the different equation is not zero. So in this case, we need to solve the non-homogeneous equation, and its solution should include homogeneous solution and special solution. The solution process is also more complicated than the zero input response of the system. Another way to solve the zero state response of the system is convolution integral method. This method will simplify the solution process. In the sixth lecture, we will discuss it in detail. For zero state response, there is a zero state response YZS before excitation axis. And the derivative of each order is zero. For zero input response, there is initial value of zero input response. The initial value of the zero input response is equal to the initial state of the zero input response. It equals to the initial state value of the system. For the case of system full response and zero minus value, they can be decomposed into zero input response at the corresponding time, and sum of zero state response. This is described in the following two formulas. Let's look at an example of a specific solution. It is known that the mathematical description equation of an LTI system is shown in the first formula. Y0 minus equals to 2. The first derivative of the total response is 0 when t equals to 0. An excitation signal is unit step signal. Find out zero input, zero state response. Let's start with zero input response. Just now we have analyzed that zero input is a homogeneous solution of the system equation. Write out the form of solution according to the condition of characteristic root. The undetermined coefficient is determined by the initial value of the zero input response, determined by the initial value. That is, CZI1 and CZI2 in this equation are determined by the initial value, which is determined by the initial value of the system response. For zero input response, the initial value of the zero input response is recorded as its initial state value. We take its initial value back to the solution of zero input response. Then it can be found that CZI1 and CZI2 are equal to 4 and negative 2 respectively. The final zero input response YZIT is equal to 4 times the negative T density of E minus the 2 times of the negative 2T density of E. The solution of zero state response is more complicated. It's composed of homogeneous solution and special solution. We replace the excitation signal with the original equation. You can get this relationship. By integrating the equations, we can obtain the initial value of the first derivative of the zero state response, the initial value of the first derivative of the zero state response, the value of the first derivative of the zero state response. At the time of 0 plus is equal to 2, It's not difficult to see from the screen that the homogeneous solution of the system should be that YZST equals to the negative T density of CZS1 times E plus the negative 2 density of CZS2 times E. Since T is greater than 0 plus, the right end of the equation is 6, so we can find that the special solution is equal to 3. Using the initial value of the system, we can get the undetermined coefficients CZS1 and CZS2, which are -4 and 1 respectively. Finally, we get a solution of the zero-state response, equal to the negative T density of E plus the negative 2 density of E plus 3. This is the result of zero-state response. That's today's lesson. Thanks.